Okay, so the first question that we need to ask is that why do animals need movement? So you all can just answer in the chat box.
So friends, you have to respond on chat box. Okay.
Scavenging for
One
food.
answer, two answers have come.
Right. So lots of searching for food, searching for shelter, and basically so that they can survive and so they can do many things. Like to do anything an animal needs to move, because otherwise it would be, if it was stuck in one place, there's only so much it could do. It couldn't go after its food, it couldn't find different shelter, it would be stuck in one place. So animals need movement. So now can you, so of the things that you said so far that animals need, like the scenarios in which they need movement, can you tell which cases they need very quick movement in? Ma'am, next slide. Okay, Anya Mohan said if they are hunting or being hunted, those are like the two most common cases for most animals. So as everybody is saying, escape from predators or to catch their own prey. And there could be other times, like say there's a very sudden change in weather, they'll need to suddenly move to find shelter. So yeah, when they sense danger in general. Ma'am, next slide. So yeah, two of the most common ones are to catch food themselves, to run after some food they see, and to run away from danger such as predators. So now, how do they know that there is a predator near them or there's food near them? Like what tells them that there is something that they need to run towards or away from? Okay, so Sneha Rana said their senses. Can you give examples of its senses? Okay, so smell and hearing. Yeah, so smell, vision, hearing, that's how they'll come to know that there is something that they need to run towards or run away from. So these are their senses. So as you all probably know, we have like 5 major senses and sense organs. So we have touch, hearing, taste, smell, and sight are our senses. So then the sense organs become skin for touch, our tongue for tasting, our ears for hearing, our eyes for sight, and our nose for smell. So these are our sense organs. Now, are there any other senses besides these 5 that you know of? Right. To feel hot and cold is like being able to tell the temperature is a sense. Yeah, sense of time.
And Divya has said intuition.
Intuition is, I'm not sure it would be a sense. would you say intuition is a sense?
They let her sort of a sense where it is unconscious, means we don't know what senses we are taking in. So
But yeah, otherwise things like our sense of temperature, our sense of time. So we have other senses as well. Ma'am, can you go ahead?
Yeah, somebody said intuition is the sixth sense, and one is said vestibular. I mean, see, sixth sense is actually colloquial use. I mean, it's like everyday use saying that it is an extra sense. Though we have lot many senses altogether, as Assis said. I mean, like temperature and pressure and balance, and in fact, some scientists say there are 22 senses in all. I mean, if you add the extra ones. So, but intuition, like Swapna ma'am said, is not really a sense in that that way. The way we are treating senses here. I mean, here senses are like where you respond to changes in environment, and it's kind of immediate response to, or immediate sensing of any change in the environment, which Assis will be built. So shark have pressure as sixth sense, even we have pressure as sixth sense. And emotions, Nandana is saying emotions. So let's see if emotions will qualify as sense. Sense has a very specific meaning here, which Assis will just build. So we have just asked the question what senses we do have.
So like ma'am was just saying, when you see something, when you hear something, something in your environment is changing, right? Like you're like something is coming into your view, which is why you see it, or when you feel the temperature change, something is changing. The temperature changes, something hot is near you, so you feel that change. So when we're sensing, what we're sensing is the change in our environment. And so the change in the environment, in an organism's environment, is what we call the stimulus for that sense.
Here, one proprioception, or rather body awareness, has come as a very good response. Yeah, so I mean, these are also actually senses which we don't realize. I mean, they are not listed as major senses, but it's very important. Like, I have an extended hand, or I have my body ends where and the environment begins where, is also one sense. So Shweta has asked something. Assis, you could take that up.
Yeah, that this doesn't the sense is something that's connecting to us to the environment or making us aware of the environment. And I mean, that's basically right? Like it's making us aware of changes in the environment. Like if the environment never changed, we wouldn't be sensing anything. So it is making us aware of the environment in the fact that like when a change happens, which we're calling a stimulus, a change in the environment, then we sense it, we come to know that something is changing. So it is making us aware of the environment. Our senses, like the function is to make us aware of the environment by recognizing these changes that we call stimulus or multiple stimuli. So just to like give more examples. My next slide.
Yeah, I was just saying that you have to be you have to notice what you mean by being aware. You see, I mean, what like in sciences, we often pay attention to the common words we use. In daily life, we may use it very loosely, so being aware. But in science, you'll have to specifically define it. What do you mean by being aware? And then here's another another response somebody has got probably from the net. What are the 7 senses? So one of them is body position or body awareness. Okay.
Yeah, so to give more examples, like when we talked about running away from a predator, so the change in the environment here is the predator. So the predator is the stimulus that the other animal is running away from. So you it either heard the predator or saw the predator. So the stimulus for that sense is the predator. Or let's say we smell something really good, like good food. So that food is the stimulus. That's the change that's coming that we're sensing via our smell. So yeah, just to have it clear that the stimulus is the change in the environment. And then we are sensing it with our senses and our sense organs. So can you give me any other examples of stimuli? A foul smell, strong perfume. Hunger, I don't think would count. Would hunger count as a stimulus?
Hunger is an internal thing.
Yeah, it's fine. Okay, yeah. Temperature change would be a stimulus. Touching a hot pan, the hot pan would be a stimulus. See, smell is a sense. iPhone's skin will not be a stimulus. Skin is our sense organ from which we're sensing stimulus. Harshan says a dog is hot, so it lies in the shade. So yeah, what's the stimulus in this case? Diya, yes, the prey is a stimulus for the predator if the predator is chasing the prey. Like if a lion is sitting around, it sees a zebra. The zebra that it's seeing is the stimulus, and it's sensing it via its eyes. Right, a noise can be a stimulus.
I'm only pointing out that, see, when a zebra is there, I mean, suppose prey is there, seeing the prey, the view of it is the stimulus. I mean, view of it or hearing it or smell of it. So it's like you can think of it in terms of how you are sensing. I mean, what in your body makes you sense that stimulus. So somebody said seeing something surprising. Now suppose you see something burning and it comes as a surprise to you. So seeing that thing is the stimulus. It's like the sensing is the seeing part of it, the view.
Right.
Shweta, hunger is not a response. It's neither a stimulus, it's not a response. It's your body internally asking you for something or making some internal changes. Currently, whatever we are saying as stimulus, response, sensing, that's, I mean, particularly stimulus, this is all external to our body. Stimuli are external.
I think somebody said fear. I think that also comes in the same category. Fear,
fear
will
is
not be a
also
stimulus.
Feeling on the inside. Achha, Harshan is giving a lot of examples, but Harshan, you need to tell us what the stimulus is in these examples. Like these are all things that we do, but like what is the stimulus? And Hitesh is asking if taste is the stimulus. So taste is our sense, right? But the thing that you taste will be the stimulus. So if I put like a piece of candy in my mouth, I can taste the candy. The candy is the stimulus and my tongue is tasting it. So in that sense, taste is a sense.
Rashmi said that if we hear a joke, we laugh. So joke is the stimulus. Actually, hearing the sound is the stimulus. See, it's I mean, we must remember that content of that sound is something that your brain will interpret sometime, but I'm speaking. So the speech, which means the sounds that I'm making, is the stimulus. And now those sounds will go into your head and your brain will figure out something out of it, what I'm saying and or the content of that sound, or whether it's music or whether it's a joke or whether it's noise. That's a separate thing. But the stimulus is the sound, the changing sound is the stimulus. So even a joke will qualify it as a sound?
Sharanya is asking if chemical reaction is a part of stimuli.
Chemical reaction happening where? Sharanya, which chemical reaction are you thinking of? I mean, like the world is full of chemical reactions, but you can either see or hear or taste or touch or you can feel some pressure or you can feel hot or cold. So I mean, some chemical reaction would you would see, for example, you would see fire or you would see some change in color, but that would, the stimulus would be seeing the view of it, right? They are saying eclipse again, it's a vision, it's a view. So the stimulus is the view. The environment changed, the sun changed and became dark, so that's the that is acting as a stimulus, the change in the environment. If the temperature is bad, we adapt. So temperature going high or low is the change in the environment, which is the stimulus for you. So like Sharina is saying fire. So yeah, seeing the fire is one stimulus. Feeling the hotness of the fire is the other stimulus, which your which your skin will feel, and seeing the fire, your eyes will feel. So think of a sense organ sensing whatever is happening, the change that's happening in the environment. Think of some sense organ in your body sensing it. Antigens will be stimulus. Shweta, once again, internal. Please don't write internal things that happen inside our body. Okay, antigens is those bacteria or I mean like troublesome things which enter the body, isn't it?
Presenting a food naturally causes salivation. See, Harshan, again, you're giving full examples of what happens, but you need to point out what the stimulus is in each of these cases. So like, if you're presenting a food which is causing salivation, what is the stimulus? Right, it could be the smell of the food. It could be the sight of the food also. Generally, of course, smell is a much stronger like of the food. It could, but we could also just see the food and start salivating. Sharanya is saying nerve impulse. Okay, so Harshan, salivation is not a stimulus. Salivation is the action that we are doing, right? What you smell, like the smell of the food, that's the stimulus. Rashmi, thinking of food is also not a stimulus. Thinking of food is again, salivation is happening in our body. Thinking of food is happening in our body. Stimulus is a change that's happening outside our body, in the environment.
Nandana wants to share her screen. I will, she wants to show something. So I will enable her. Nandana, I can't get, I can't find you in the list. Let me once again try. Maybe she's dropped out. I have no idea. I mean, when I write her name, I don't get. Now I got. So Nandana, I have made you co-host, which allows you to share. So if you want to share your screen, I will stop sharing and you can share. Oh, Nandana has drawn something. Nandana, please show. So Nandana has shown what is the stimulus.
Right. So you've shown a monkey with a stick as a stimulus. And an apple for a little girl.
Yeah,
so
excellent. Yeah. Great. This is great. So shall I stop this? So I'll get back to our screen.
Yeah, so I think like we should be very clear on what a stimulus is before we move forward. So like if anybody has any more doubts about what is or isn't a stimulus.
So we'll reiterate something which we said earlier, that firstly, it should be happening in the environment. Anything that's happening or any change that's happening in the environment is the stimulus. Anything internal to your mind, to your body, hunger, thought, irritation, fear, anger, whatever inside the body will not count as stimulus. So that's what one very, very important thing you have to remember. Stimulus is outside, and which is sensed by something in our body. So like Nandana showed and we are showing, that sight of something, smell of something, touch of something could be the stimulus, or hearing something. So that's what we are calling as stimuli. Stimulus is a singular, stimuli is the plural. So if there is any doubt in this, because stimulus is a very important word in this whole thing. So please clarify yourself if there is some doubt about this. Otherwise, we'll proceed. So shall we proceed?
Yeah. Okay, so, okay, wait, there's one question. Sharanya was asking, what are the changes that occur inside our body, such as digestion cord?
Metabolism.
Yeah, that is like processes happening inside our body.
मैं काम करूँ ठीक है
Yeah, so we call them body processes or metabolism, as Swapna ma'am said. So a general term for it is metabolism. So everything inside our body, happening inside our body, is metabolism or body processes.
Okay, so a stimulus, like we talked about, is a change and we're sensing it. So the part of our body that's sensing the stimulus, which will generally be our sense organs. So like our eyes are sensing something that we're seeing. So that part of the body that senses the stimulus is called the receptor. Right? The change is the stimulus. What's sensing it is the receptor. Okay, where is this organ seen? Nandana, I didn't understand which organ.
Nandana, I'll receptor.
So receptor is any of our organs that are sensing, right? So our skin, if we're touching something, our skin is a receptor. If we are seeing something, our eye is a receptor, right? So our eyes are on our face. So that is the receptor. Receptor is just another word for the organ, the part of our body that's sensing something. It's not a separate organ called the receptor. All of these things are receptors for different stimuli. Right.
So is the idea of a receptor clear?
Niveta asked, so basically all the sense organs are called receptors. Yeah, but like, they'll be like when you're seeing something, only your eye will be the receptor for that stimulus. So you won't say that that your skin is also a receptor when you're just seeing something. Okay, so now our receptor has taken the stimulus. It sensed the stimulus. So now, fear is not a stimulus. Fear is a feeling. We've talked about fear is happening inside the body, so it can't be a stimulus. Something will make us feel fear, that will be something that we see or something that we hear. Fear itself is not a stimulus. Just remember that everything inside our body is not the stimulus. Stimulus is happening outside. Okay, so yeah, we've got the stimulus. Now our body needs to decide what to do with that stimulus. Like we see something, we usually don't just, do nothing. It's not that predator ko dekh liya and we're just sitting there, right? The body has to decide what to do with it. So there's a part of the body that decides this. For now, we'll call this the command center, right? It's taking all the decisions. Okay, what you have to do. So the stimulus will go from the receptor to the command center. Ma'am, next. So now the question is, how is the stimulus reaching the command center? Like we've sensed the stimulus, but that is at our sense organs, our receptor. So how is the command center going to find out that how we've sensed the stimulus? How is it reaching from one place to the other? Okay, Nandana has said nerves. Right, but what are, okay, so you all know that nerves are involved, but what are the nerves carrying? Like right now, let's just talk about like, not what is doing this stuff, but okay, Meenakshi has said signals. And Shania said instructions. So yeah, the nerve will carry messages, right? Like so just to make it clear to everyone else what a signal is, since everyone might not be able to understand what a signal is, right? One of you has said signal, but like, so what is a signal? So if you've seen a message, like, have you ever seen any messages travel from one place to the other around you? Can you tell me any examples? Like where you send something from one place and it reaches someplace else. Okay, WhatsApp messages, post, emails. Yeah, so we see in our emails or WhatsApp messages that they're reaching someone else, but these we can't see. A very way to see it is post. If you post something, it'll reach someone else. So, it's traveling across a distance, reaching someone else. Now, next slide. So in that way, our body is also sending something from the receptor to the command center. And that message that's traveling from one place to the other is a signal. Right? So we'll call these signals. Right. And then, so now a signal has gone from our receptor to our command center. Our command center takes a decision, and then it will send another signal back to take an action. So the part.
Assis, I'll just add that, I mean, here you can see a physical thing, I mean, which means you can see a letter or a box being handed over. So that we are treating as the signal or the message. So here the letter has the written message, the box has some material as the message. But when you say email or WhatsApp or a telephone, there the signal is a pulse of electricity passing. It's like electricity passing through wires. I mean, normally electricity, but it could also be some rays passing through the environment, through the space. So that is the signal. So actually, though, because as he said, they are invisible, so we don't see those as signals, but the signal could be an electric, a burst of electricity, or it could be a burst of rays, special rays, or radiation. That could be the signal. But I mean, the letter or the box can be very easily seen. Yeah, please carry on.
Yeah. So now the command center will send another signal back into the body. It's taken a decision of what has to happen. So another signal needs to go and tell some part of the body to take an action. So the part of the body that will take the action is called the effector. Now, ma'am, just go again. Right? So the command center will send a second signal to the effector. Oh, there's a question. Suppose a person tries to shoot someone with a gun and the person does not know what a gun is, so he will not react. I mean, yeah, I suppose like you might react to seeing something new, but yeah, you might not react if you don't know what a gun is. You're still seeing the gun though, right? You're still sensing that there is a gun. What your brain is thinking about it happens later. You're still taking in the stimulus. And then, yeah, maybe not reacting is what will happen. You won't react.
So the person may not know what a gun is, but the person may realize that the person is trying to do some harm. So brain can work in different ways. So we will probably not talk about it.
Yeah. So yeah, here just like, so the effector is what is taking the action, right? So just how the stimulus is different from our receptor is what is sensing the stimulus. The effector is different from the action. Effector is our body part. Action is what it's doing. Similarly, receptor is our body part. Stimulus is what it's sensing. So let's go back to smelling something nice, right? Our receptor here is our nose. It's the stimulus is the smell of the cookies. So that sends a signal to the command center, which then sends a signal to our effector. In this case, it will send a signal to our salivary glands to cause saliva in our mouth. Right? The action is saliva being produced in our mouth. The effector is the salivary gland. Right. So just like pay attention, the receptor would be the nose, the effector will be the salivary gland. And the stimulus is your smell. The receptor is taking in the stimulus. It goes to the command center. Command center says.
Assis, just unmute yourself.
Yeah. Salivary gland, which is the effector, will then cause saliva to be produced. Similarly, if we get, like if we touch something sharp, we get pricked by something sharp. Ma'am, next slide. Here, the sharp object is the stimulus, right? Our receptor becomes our skin. We're touching something sharp. It's like we're sensing it with our receptor. Now, the signal goes to the command center, which will say, okay, we are going to tell the muscles to move the hand away. So the command center will send a signal to the muscles, which are the effector. And the effector then causes the action, which is to move the hand away. So do you understand how, like, with every receptor, there will be a corresponding effector to cause the action? So yeah, can you name any more receptor effector pairs?
Yeah, think of examples where there is something in the environment and some action is taken by your body. Hot stimulus by tongue. Kamya, you'll have to say what is the stimulus here and what is the action. I mean, who has received the stimulus? Somebody receives the stimulus. What is the stimulus? Who has received it? And then in response, who's taking the action, which means the effector. So you have to tell all of these. So in that your hot tongue case, what is the stimulus? Who receives the stimulus, which means the receptor? Then who acts, and that is the effector, and what is the action? 4 things.
When we fall, the ground is the stimulus and our body is the receptor. I guess our body would be the receptor of touching the ground, yes. But you need to also then tell us what will we do in response? What will be the effector? Okay, Meenakshi said stimulus play, receptor eyes, effector muscles. Yeah, this is correct. So if we see play, our eyes are the receptor and the effector is the muscles taking the action.
And generally what muscle, Meenakshi?
Yeah, that's also important, that all muscles will not be the receptors.
I mean, your face muscles may not be the receptor, your tongue may not be the, sorry, tongue muscle may not be the effector. Which muscles would be the effector? When you say muscles, you'll have to specify which muscles, because muscles are all over your body, including your face, hands, tummy, your intestines. Muscles are everywhere.
So she has answered legs, I think.
Yeah, so she said
yes.
muscles of the legs. Yeah. Okay, we have more. Nivedita said when we touch something hot and take our hand away from it, the receptor is the skin, stimulus is the hot object, the effector is our hand, the brain acts and delivers a message. Okay. So the effector is not our whole hand, right? The skin of our hand will not be the effector. It's the muscles that will be the effector. So just like in that case, like it will be the hand muscles.
Sneha is asking whether she's right.
Mummy called me, so it's stimulus. My ear is the receptor. And then if I go there, my legs are the effector. See, you're mostly correct. Again, just pay attention that your legs as a whole will not be the effector, right? The part that's taking the action will be your leg muscles. But yeah, your legs are moving. Asai Praneshad said, if our eyes see a rupee, it will send a message to the command center. The effector is our hand, we take it and give it to the police. Yeah, again, it will just be our hand muscles.
So the response is your hand, or action is your hand moving. Whether it's given to the police or put in your pocket is not, doesn't matter.
Where it's moving is the consequences of the action. But the action is that it's moving. Shweta said that someone trying to hit you. Eyes are the receptor and the muscles of leg are the effector. Moving back, yeah. Dia said change in temperature, skin is the receptor and the muscles of the hands are the effectors. Rajeshwari is asking that if the mosquito bite is the stimulus, skin is your receptor, effector is the hand muscles, or is it the skin the effector? So the immediate effector would be the hand muscles, but the skin is, I think that's more of a physical response, right? It's not some action that you're taking. That's the way that the skin physically responds to the bite. Okay, I think you all got the hang of it. Everybody is giving the correct examples.
Nandana wants to share her screen again. Nandana, I'll just make you co-host again. I mean, it's nice that one participant is trying to herself show things. Yeah, Nandana, now you can. She's making it very visual, very nice. Nandana, please send some of these to us.
Okay, ma'am.
Yeah, thank you.
Yeah, thank you so much. Right, should we move ahead? So this is just an overview of what we've studied so far, right? That the stimulus is sensed by the receptor, which is the sense organs usually, which send a signal to our command center, which send a signal again after taking a decision. It sends a signal to the effector, and the effector takes an action, right? Are there any questions up till here? Like if you've understood this process, this flowchart, then we'll carry on.
So friends, you have to tell us whether we should move. I mean, that's like kind of a signal that you should, or rather a stimulus you should give us for us to take our session further. So move our mouse or whatever. Signal coming from others, should we move ahead? Or you want to ask us a question?
Okay, I think everybody is saying yes.
Okay. Great. Yeah.
Okay, so now we're going to talk about what this command center is and what the signals are. So first, let's talk about the command center. Does anybody have an idea what the command center is? Some of you have already mentioned it before. Right, so our brain will be one part of the command center. Another part will be the spinal cord. So yeah, the brain and the spinal cord. It's just an image here to show you like how the spinal cord runs through our body. You know where our brain is at the top of our body in the skull. These will be the command centers. And we've got a very interesting activity to show you how the brain takes the signals and decides what to do with them. So when we see something, our brain decides what we're seeing. So here's a very interesting activity. So if any of you can take a sheet of paper.
Ridhima, neuron is not the command center. We'll come to the neuron very soon.
Yeah, very soon you'll get there.
Yeah, but then command center is not the neuron. Neuron itself does not take the decision. The brain or the spinal cord take the decision. They are themselves bunches of neurons, but yeah, they are the command center.
Okay, so let's do this activity. I want you all to take a sheet of paper, right? Take a sheet of paper and roll it up. Roll it up into a tube like this. So once you've done that, what you need to do is hold the tube against one eye and then take your other hand and hold it a bit, like not touching your eye, but hold it ahead, touching the tube. So do this and tell me what you see.
And both eyes should remain open.
Yeah, both eyes open, looking at the tube and your hand. If any of you wants to like turn your camera on to show yourself doing this.
Sneha Rana has already said. Babita has said.
Yeah, Rajeshri, I'll repeat. You take a piece of paper, you roll it up along the long side. So you make a tube. You hold the tube against one eye and you take your other hand and hold it against the tube. And then you look through both eyes. And then you say what you see.
So some people have already said that they are seeing a hole in their hand. So you see, Assis is a magician. She can make holes in your hand just by saying, just by command.
Right. So you all seem to be seeing a hole in your hands. Now, why do we see a hole in our hands, right?
Anyone having difficulty doing this? Anyone who has not managed to do this or is not succeeding? Please let us know. It could be at the edge if you put it in a certain way, but it could be even through the middle. Nandana, you're seeing a small part, but if you keep it, I mean, like kind of straight, the tube is straight in front of the eye, you can see the hole even in the middle of your hand. In fact, we have a picture of it also here. I'll show you the picture. Like this.
Yeah, like if you look at a wall, it really just looks like there's just a hole coming out, like in the middle of your hand. Right, so if everyone's done like doing the activity, we can talk about it. Is anybody still doing it?
So should I go to the next screen?
Yeah, you can go to the next screen. So what's happening here is that both of our eyes actually take two different signals, right? Like when we look at something normally, this is to a separate case, a case where one eye is looking at something different, one eye is looking at something different, which is, and our brain takes these signals and fuses them together. So this happens because when we look at something normally, there's an overlap, right? Our left eye will see something which includes a bit of the center area. Our right eye will see something which includes a bit of the center area. And our brain sees these two different signals and takes the decision that, okay, these are not two separate things completely. There is some overlap. And our brain will form one image, like using both the signals. So this is why when our two signals don't have an overlap, our brain causes the overlap. So yeah, this is just an image showing like how the overlap, like the overlap area between the left and right images. In actuality, it's not such a small overlap. Next slide. Actually, our eyes have a really large overlap and just slight differences on the left and the right. So which is why most of what we see, like with the hole in the hand, is our brain just overlapping the two signals that our eyes are giving. So this is just a very interesting thing about how the brain is taking these signals and using them. So now, if this is fine, we can move on to how do the signals move. We know that there's a signal going between the receptor, the command center, the effector. How is the signal going there? How is the signal moving from one place to the other? So if anyone wants to answer, you can, otherwise. Right, so most of you seem to know this, that it's by nerves. And what are these nerves? Nerves are specialized cells. Right, we like the body realized that it needed these specialized cells to carry this signal. Ma'am, next. So these specialized cells that carry the signals are called the nerve cells or the neurons. Now, you all must have seen a cell, like you must have some idea what a cell looks like. Does this look like a normal cell to you? And if not, tell me what parts of it look different. Anybody, like there are some differences to how you know a cell looks like and how this cell looks like, right? Okay, Nanda saying it's the longer cell. It definitely seems to be very long. Meenakshi saying multiple dendrites. Dendrites is fine as a name, but what are these dendrites? What are you seeing? Nanda, veins is a separate part of our body. They do look slightly like veins. The point is they look like branches, like threads coming out of the main body, branches coming out of it, right? There's all these little branches coming out from the top, and then a long part. Yeah, Tia says it looks like there are roots. So there's this long part that then comes out of one side of the cell, and then it looks like that part has roots coming out of it because there's more branches. So these branches at the top of the cell are what we are calling dendrites. These branches are going to take in the stimulus. Like they're branched out like this so that they can spread out, take the stimulus. And then the axon is long. The long part is called the axon. And why is it long? So that it can carry the stimulus. Sneha, we'll just come to that in a minute. So the axon is the long part. It's going to carry the stimulus because if a nerve cell wasn't long, if it didn't have this long part, you'd need so many cells, right? Ek nerve cell, how can you reach from, like say you touch something on your hand, How do you reach from your hand all the way to your brain? If the nerve cell was just a circle, you need so many, right? But since the nerve cells are long, you need slightly less. They go along and connect to each other and go all the way up to your brain or your spinal cord. So this is why these cells look like this, right? The dendrites pick up the signals, the axons carry the signals. And so now we just have some images also of nerve cells. So the first one you can see is through a normal like light microscope. It's a nerve cell, just like you can see the big round part, the dendrites coming out of it, and then the axon stretching off into the corner. The second image is a scanning electron microscope, a very powerful microscope showing a nerve cell. A single nerve cell, you can see the branches coming out of it. The third image is very interesting. So this is how we can actually see like what, not the cells, but we can see how the nerves look like. So this is at the bottom of our spinal cord. All these threads that you see, these are bundles of nerves. Many nerves like kind of, joined together. So you can actually see like these bundles of nerves passing through our body. So if you like cut open a spinal cord, you can actually see these. So now we've talked about that the dendrites are sensing things. So like, where do you think that the dendrites will be located in our body? Right, like if you're if you're touching something sharp or we're smelling something nice, where are the dendrites in these cases? Skin. Yeah, below our skin. Any other answers? Like any specific areas of our skin? Like say we're smelling something. Where are the dendrites located when we're smelling something? In our nose, right? So the dendrites will be most present in our sense organs and at our extremities. So like the nose will have a lot of dendrites, the ear will have dendrites to pick up the sound, and then our skin will have dendrites, but they'll be more at the ends of us, like our body. So like our fingers will have many more dendrites because we're touching stuff with our fingers, right? We're not going and touching things with our elbow. So our elbow doesn't need to have so many dendrites. And we'll just wait for Anshul to come back. Yeah, so then we have just one picture of like the actual dendrites, the nerve endings in our skin. Like this is just a diagram showing how, so under our skin, the nerves just like splits into all these dendrites at the bottom, like touching out, like spreading out in the skin to touch things. So now we can actually like demonstrate how you can touch, like how there are more dendrites in your fingertips and the places you're actually touching from. And as you go more along your body, the density of the dendrites decreases. So we're going to show this to you with an experiment. You can also do this if you have some pens and another person. So yeah, Anshu ma'am.
So friends, I have Tekchan Bhaiya here, and see, I have taken 2 pens and created two tips, I mean, a little distance. So I've stuck another pen in between so that there is a distance of more than a centimeter. I mean, about an inch distance between these two pen tips. And I have a single pen as well. So I have a single pen and two pens. So Tekchand Bhaiya, I will kind of like poke this in different parts of his body. He's blindfolded. He can't see. So I will just ask him one or two. And he has to tell me whether he's feeling two pinches at the time, at one time, or one pinch. Right? So he will say one or two. Okay? So I am beginning. So Tekchand, आपको एक या दो बताना है ना?
एक
जोर से बोलना.
एक दो दो एक दो एक 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 दो एक दो 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 एक 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 दो एक एक.
Thank you. So did you see, friends? I mean, well, I could be making some mistake by applying pressure unequally. See, these two should pinch equally or like prick equally. So, I mean, if I put pressure differently, he could be mistaken. But very clearly, the palms and front and back of hands and fingers are extremely sensitive. They must be, I mean, yes, as Rajeshwari is saying, number of dendrites are more definitely in the palm and fingers. I mean, this you can very easily do at home with somebody else and try discovering where there are more dendrites. The surprising part is the back. Look, just look at the distance between these two. I mean, this is quite a lot, but often the back portion sees it as one or experiences at one, because if there is like one dendrite here and the other dendrite is far away, the in between prick will not even be felt. The whole thing will be felt as one. So back is rather insensitive. In this case, when I was doing with Tekchand, like there was a little difficulty. I mean, sometimes on the back also he felt too, but it's possible that both things are possible. Both things are possible, that two dendrites came his way, or possibly I applied pressure, more pressure. So, I mean, well, the results won't be so accurate, but you could see that there's very clear difference between arms, back, and like, okay, neck and hands, definitely.
Yeah. Nandana is saying that maybe because he's wearing clothes, that's why he felt one instead of two.
Nandana, it's like when you do an experiment, yes, I mean, you are right that maybe clothes make a difference. So, I mean, you can actually try this on exposed skin. See, of course, we like, if you have to be like true scientists, you have to like remove all sources of error. So think of what sources of error could be there, but scientists actually do this experiment to test the sensitivity of skin in various parts of the body. and it definitely varies.
Yeah, and we've tried it once ourselves also with some exposed skin on the back. And like the results are there. You feel like you can't always tell if it's 2 on the back. On the fingers, you can always tell if it's 2 pricks or 1 prick.
And of course, like any good experiment, there should be large number of takes. I mean, a good experiment will take so many readings. So do it 20 times, 30 times, 40 times, and the average is taken. That's what scientists do to remove error.
Okay, so should we move ahead?
Yeah. I mean that I'll need to go and get the multimeter. So I mean that's a little far away, no? So I'll just
that's decided. The other video in the middle. I'll show the PPT till then.
Okay. So Nandana has asked a question. You can maybe respond.
Yeah.
So I will. Yeah, you can show the PPT till then. I'll just.
How much time will it take to a receptor to reach the command center and give message to the effector? See, I don't know the exact amount of time, but generally our nerves work very fast. It's not like instantly it will just happen. Like in most cases. In most cases, it will take a little bit of time, but like, you think about something and you do it, right? It's not that you're waiting for a very long time and then you do the action. So I don't know the exact amount of time that it takes. Swapna, if you know, you can say, but like it's a very fast process generally.
Yeah, it's very, very fast. It's less than second. Just ask, all of you can think that if you walk in and if the light goes out, how fast do you know that there is light has been switched on or light has been switched off? It's very instantaneous, maybe less than a second. Okay,
Yeah.
Very, very fast.
Okay, so now we know that nerve cells are like the ones carrying the signals. So now the question is, how do they send these signals? One nerve cell can't go along your whole body, right? There needs to be a way for them to communicate with each other. So like, okay, this is obviously, they're very small, but say I had a nerve cell here and a nerve cell here. This one would have to tell this one, like send the signal to this one, which will then carry it here, then here, then here. And that way it goes throughout the body. So how do they send these signals? So they send signals through a connection between their axon and the next nerve cell dendrite, which we call the synapse. And the signal is in the form of chemicals that we call neurotransmitters. Right? So nerve cell is the neuron. So neurotransmitters, these are the chemicals. So now I'll just show you a video of a synapse, of a signal being sent from one nerve cell to the other through this synapse. So this is obviously not real. They made this out of clay, but there you've got a nerve cell. You've got its axon ending in all these branches, and it connects to the dendrites of another nerve cell. Right? So where they connect, that's called the synapse. And this is a signal. You see how it goes from one cell to the other cell? And these are the chemicals, the neurotransmitters going between the synapse. So just look at this. they've shown how the signal goes along one cell and then goes to the other. I'll just show this part of it again. So we talked about
So Assis, I'm here with
yeah, just finishing this part. So we talked about how this is an invisible message, right? This isn't like a mail that you're sending where you can see it. It's more like the invisible messages that we talked about, like say your WhatsApp message. Now, those are electric signals. And what we actually see is that these signals are also electric signals in a sense. So you see how there are charges along both sides of the axon. So there's negative charge inside, positive charge outside, and a pulse moves along this. So it's an electric pulse. So these signals that the nerves are carrying, that they're sending from one nerve to cell to the other, up to the command center, back to the effector, these are electric signals. Now, of course, if there is electricity, like electric signals moving through our skin, we should be able to find some evidence of it, right? So Anshumala ma'am will just show you how we can see that there is some evidence that these electric signals are moving through us.
So friends, here I have a multimeter, right? A multimeter is a very fascinating device. So, I mean, you can set it on voltage and current and all that. So currently I will set it on, I mean, there is a millivolt section. So 200 millivolts. Here's 200 millivolts, and which is like millivolts is a very tiny voltage. I mean, you know that a simple battery is 1.5 volts. So this is millivolt, which means like 200 millivolts, which means nearly a fifth of that, 1/5 of 1 volt. So, I mean, which is be a very tiny voltage. So, I mean, in the environment, wherever there is little charges moving, you should be able to see. So what I'm trying to show is, I'll hold it like that in my hand so that you can see the readings. And I'll show voltage across my two hands. Across my two hands, I mean, you can see some reading. And across my, wait, this has become a little loose. This one is a little loose. So I have to show it to you, the reading. No, once again, not giving any reading because this one, I mean, there was another one which I didn't find, the one which was working all right. This one is a little loose. Otherwise, you are able to see readings. And now it's like, showing some reading. So you can see it's showing some millivolts across my two hands. Like you can, and the reading would normally keep changing. So across my two cheeks, across my two temples, and even any place in my two hands. So this is evidence of like some electricity flowing. See, some electric charges flowing, which is basically nerve impulses. basically what I'm seeing as millivolts in this device is basically showing some nerve impulses flowing through my skin. And I mean, this one goes loose many times, but I mean, you can see that when it's like working, you can see some difference in the two sensors. It only means that there's difference between charges here and here. That's all it means. And this will, of course, keep changing as you take it to different parts of your skin. Right now it's 0. They are not touching my skin. So, right. So, I mean, we can actually see evidence of some electrical signals across our skin. Yeah. So should we move to the next part?
Yeah.
So we have you talked about synapse?
Yeah, I've talked about the synapse.
So you can take any questions if somebody has.
Yeah, I was thinking let's just do 2 more slides and then we can take questions and then.
Okay.
So now we've seen that we've talked about how there's all these nerves going all over our body. So what does it actually look like? So here's just 2 images. So on the left, it's just showing like how the nerves go all over our hand. Like you see all these nerves crisscrossing, going all the way to our fingertips, right? This is why our fingers are so sensitive, because the nerves are going all the way to our fingertips. And then those are branching out into dendrites. And on the right is it's just showing how the nerves are spread all over our body. Now we call these nerve fibers because they look like fibers, right? They are a lot like cables. Now you might be looking at this, it looks a bit like the circulatory system, right? So you just need to remember that the difference is circulatory system is like pipes, right? It's like lots of pipes going through your body carrying liquid. Nerves are more like cables. They're like, data cables you might have seen connecting your internet, like to your computer or to your, so they are, or even like the cables that take like phone signals like all over. So the nerve fibers are like data cables going through your body, and the circulatory system, the blood vessels are more like pipes. So just like don't get confused between these 2. Yeah, so now if there's any questions up till this point.
And let me add that as a child, I completely mixed up between nerve fibers and blood vessels. Because both look the same and nobody made it very clear to me. And what is worse is in Hindi, we use the same word nas for both. So nas is used in daily life. Nas is a very vague word. Sometimes it talks about blood vessels and sometimes it talks about nerve signals. Actually, in daily life, people don't even realize that there's something called nerve signals, nerve fibers. I mean, blood vessels are actually visible. So blood vessels, there's still some understanding, but nerve fibers, none whatsoever. So when people say nas chad gayi, nas khisak gayi, nas mein dard ho raha hai, nason mein dard ho raha hai, they could be meaning either of these 2. So one has to be conscious that there's a lot of confusion in children's minds about this.
Okay, so this is the arc we've talked about till now, right? That the stimulus is sensed by the receptor, which sends a signal through the nerves to the brain and spinal cord, which sends another signal through the nerves to the effector, which takes an action. Now let's take up a specific example. Let's say I throw a pen at you. Okay. So the pen thrown at you is the stimulus. Your eyes see that there's a pen coming towards you. So your eyes are the receptors. They send a signal through the nerves to your brain. Your brain decides you need to catch it, sends a signal to your arm muscles, and your arm muscles catch it, right? So this is your full like arc of like one action. Like a pen is being thrown at you and you catch it, and this is what's happening entirely inside your body. So now that you've seen this full arc, can you tell me that this action, do you do it knowingly? Like Are you catching the pen knowingly? Like, are you catching the pen on your own, or do you know that, I want to catch the pen, I'm catching the pen? Hide says no. Nanda saying to repeat. Nanda, I'm just saying that if I throw a pen at you and you catch the pen, are you doing this knowingly? Like, do you know that, like, I want to catch the pen, I'm going to catch the pen? Or is it something that just happens?
So most people are saying no. But suppose I decide not to catch the pen. I mean, the pen just comes and hits me.
Yeah,
And
or
for
it fly
catching,
by you.
for catching, I have to move my hand like that and take it in the correct place. So I must have decided that I have to catch. Then only I will move my hands and try catching it at the place where it is. You would probably flinch. So suppose you decide not to catch it, so you will flinching means you will like move away so that it doesn't hit you. So even that would be a conscious thing, isn't it?
Yeah, you're still deciding what to do, right? See, everyone's saying reflexes and reflex action. We'll come to reflex action, but this is not a reflex action. This is something that you're deciding, okay, I want to catch the pen or I don't want to catch the pen.
I mean, you can think of a cricket bowler trying to catch a ball coming to herself. I mean, she can decide whether she wants to catch the ball or let it drop. I mean, too difficult, too far away, she'll, or like too much to the side, she decides no, she can't catch it, so may leave it. Nivedita saying it's not involuntary, but Assis never used the word voluntary or involuntary. She's asking whether you know that you are catching, whether you are realizing that you are catching.
Meenakshi saying data stored based on previous experiences, calculations are done instantly. See, previous experiences will tell us what we want to do, right? But our brain is still thinking that we want to do this based on those previous experiences. It's not something that's happening completely instantly. Like your brain is still taking that time. Like we talked about how, this whole process happens very fast. It does happen fast. It's not instant. You're still thinking. So like when you catch a pen thrown at you, it's still something that you're thinking about, something that you're doing knowingly. It's a reaction from the effector. Yeah, it is your effector. Like the effector is your arm muscles catching the pen. But the point is that is it being done knowingly or not? And it is being done knowingly. You are deciding, okay, I want to catch the pen or I don't want to catch the pen. It doesn't just happen on its own. Rajeshi, the difference between flinching from fire and catching a pen, we'll come to that.
I mean, what do you mean by flinching from a fire? I mean, can you describe a situation? Stimulus from a hot object, which means you touch a hot object. You touch a fire. Okay.
Yeah. So we'll come to how that's different. Right now, we're just talking about like actions that you do knowingly or not. So ma'am, can you go to the next? So now we'll give you a list of a few more actions, and you tell me which of these do you do knowingly, which of these do you not do knowingly. So one is breathing, one is picking up your phone. Then there's eating your dinner, there's sneezing, swallowing food, speaking, and blinking. So which of these do you do knowingly? Which of these do you not do knowingly? Okay, so Nandana said that sneezing and blinking we don't do knowingly. Hivdesh has said that breathing we don't do knowingly. And the rest of them? Okay, Nivedita has written breathing unknowingly, picking up your phone and eating dinner knowingly, sneezing unknowingly, swallowing food and speaking knowingly, and blinking unknowingly. Okay, and Rajeshi said eating dinner, picking up your phone and speaking are done knowingly. So yeah, this is like, I think all of you are more or less correct about what is unknowingly, what is knowingly. Ma'am, can you go ahead? So yeah, breathing, sneezing, blinking, these all, they just happen. You don't think about them. Picking up your phone, eating your dinner, speaking, and even swallowing your food. You have to think about these things yourself. Swallowing your food is a bit debatable sometimes because kabhi people say, ho jata hai apne aap, you're doing something else. But you are thinking about swallowing your food. Your food doesn't just go down itself. You have to think, swallow food. So these actions that are happening unknowingly, like that are just happening on their own, that you don't have to think like you're not really thinking while doing them. They're just happening. These are called involuntary actions. And the one,
has raised objection.
if we need, we can hold our breath, right? So the way I would see it is that breathing is the action that is happening involuntarily, and stopping breathing is something that you do voluntarily. So yeah, you can hold your breath, you can control your breathing, and if you wanted to, you can start breathing voluntarily also. Like if I want to, I can now start doing like I can control my breathing, but even when I'm not controlling my breathing, it is happening. So you can voluntarily breathe or decide not to breathe, but you're not constantly voluntarily breathing. It does happen as an involuntary action.
When you are sleeping or you are unconscious, you're still breathing.
Right. So yeah, there are involuntary actions and there are voluntary actions. And then, so there are a special type of involuntary actions also. So like you were talking about a hot pan, or you could try this, like have someone move their hand in front of your eyes. You could even try moving your own hand. Like you could just do this and see what happens. Like it's very hard to not blink, right? Just try doing this. Yeah, you blink. You have time to think that, oh, I need to blink.
Rajeshwari has asked, do we swallow when we sleep? What do you think, Swapna ma'am?
Not sure about this song.
Yes, we swallow to some extent, but our saliva production really goes down when we sleep. So we need to swallow very, very less.
I suppose saliva must be just sliding down inside.
No, it's just really, saliva production is really controlled during sleep. So it's a very interesting mechanism because some people drool. See?
Yeah.
Yeah, and the drool comes out.
You know. So there is a problem if you drool. Normally you won't drool. Normally saliva production is very less and you will swallow that little bit of saliva. As ma'am said, it will just go down. But if you don't do, normal process is not happening, then only you will drool. If you do ourselves, yes, because you know that it is coming.
Yeah. Like when
And
you know it's coming, it's not as like, you don't need to react to it because you know. But if somebody else does it, then you can't like control. It just happens on its own. So like somebody was saying earlier about touching a hot pan, right? Again, you don't touch the hot pan, then think, okay, it's hot, I should remove my hand. You touch it, it's very hot, your hand instantly goes away. Because so like your body is trying to protect you, right? So these actions that happen immediately without thinking are what we call the reflex actions or reflexes. So this is how like touching something hot is different from catching a pen. Catching a pen is not something that happens without thinking, just on its own, because your body doesn't like register pen as like something that immediately is going to like hurt you. You touch something hot, your body is attuned. Okay, this is going to hurt you. You need to move your hand away. And so the interesting thing about reflex actions is, like I said, they happen immediately, right? They don't have time to be thought about. So what our body does, which is really interesting, is it does not take the signal to the brain. So for a reflex action, this like the path is similar. You have a receptor, a signal is going, a decision is being made, signal is coming back, effector is doing an action. But what happens in this case is that the signal goes not to the brain, but to the spinal cord. So it's a shorter distance and immediately it comes back and the action happens. So there's no thinking involved. It's like almost programmed in a way inside the spinal cord what action to take.
Rajeshwari is saying, so there's hope for people addicted to phones. You think that looking at the phone is a reflex action? or I mean, well, it almost becomes like a reflex, but it's voluntary.
It is voluntary. You are thinking while you're looking at the phone.
Or screen addicts. Yeah, it almost is getting involuntary for me. I check the phone without realizing.
That becomes like also habitual actions, which are then I think a more complicated thing in that sense. Okay, yeah. So moving on, let's just for one final thing in the nervous system, let's talk about the brain. We briefly talked about the brain earlier. Now let's actually look at it a bit. Now, some of you might have seen those very confusing diagrams of the brain with all these parts, all these twists and turns and everything. So we're going to show you just a simple diagram. The brain has 4 main parts. Like all we need to worry about right now is these 4 parts. So there's that big cerebrum, the big part which takes up most of the brain. That's called the cerebrum. In the center of that, like just in the middle, is the hypothalamus. Coming down from that is a long part which we call the medulla. And then behind, in the back of the brain, is a small spherical part called the cerebellum. right? So these parts of the brain all do different things. Like we've talked about how there are voluntary actions, involuntary actions, reflex actions, of course, are happening at the spinal cord. But all these other actions, all these senses, the different parts handle them differently. So let's see what they do. And next. Oh, and this is a photo of neurons inside the human brain. Right. So our cerebrum, the big part, the big pink part, that does the thinking and it registers the senses. And so any voluntary actions that you do, so when you're catching the pen, that is happening up in your cerebrum. Then the medulla is responsible for the involuntary actions. So like the breathing that's happening on its own, this, like, you know, the blinking that you keep blinking, right? You don't think about blinking, it just kind of, you blink every now and then. These are all controlled by the medulla, which is the part in the center. I'll just show the brain again once. So yeah, this medulla, the long part, sorry, in the center, the long part in the center, which goes out of the brain, that's the medulla. And the big part, the cerebrum, that is controlling our voluntary actions. The medulla is controlling our involuntary actions. That leaves the hypothalamus and the cerebellum. So the hypothalamus is very interesting. It doesn't directly control actions, but the hypothalamus controls our sense of temperature and our sense of time. Like if we didn't have a hypothalamus, we couldn't tell if it's hot or cold. We couldn't keep track of time. Like, you know, you have a sense, like, hi, it's been 1 hour, it's been 2 hours. That is what the hypothalamus does. And then the cerebellum, again, does very specific things. That cerebellum controls precise voluntary actions and also your balance. So if you're walking like in a straight line, that's because of your cerebellum, that small part in the back of your brain. That's what helps you walk in a straight line. Otherwise, you just fall over. And precise actions. Like, Kelo, you're writing something. Very simply, you're just writing something. How does your hand write those exact letters? That is because of the cerebellum. So you see, all these 4 parts are responsible for different things. And this is responsible for everything. Now, next slide. Like the brain is controlling all of these things. You're just any action you're doing, whether you're thinking, whether you're like, you know, thinking about it knowingly or not, anything that's like just controlling of an action, your brain is doing all of this and it's doing so much more. So the brain constantly works. The brain needs a lot of energy to do this. So it's really like, you know, running this whole show. That's why we call it like, you know, that is where the control comes in, the coordination and the control. Like it's the brain. The brain is doing all of this. Repeat the functions of cerebrum and medulla. See, cerebrum, very simply, is just doing a lot of stuff. It's doing your voluntary things. Like any voluntary actions you do is cerebrum. Any thinking, like when you're just sitting and thinking about something or daydreaming about something, that's a cerebrum. And your senses. So when you sense something, that signal goes up to your cerebrum first. Because the cerebrum registers the senses. Like we talked about the eyes, right? How the brain takes your signals from the eyes and decides how to see it. That's all happening in your cerebrum. Medulla simply is responsible for your involuntary actions, your breathing, your blinking, all these things that you just keep doing. Is that clear? Okay.